Hello, everyone, and welcome. This is a bonus conversation, if you will. And in this, I'm going to go over some kind of concepts that are related to classification and particular kind of where you'll probably see a lot of them being utilized. In particular, I'm going to talk about machine learning. I'll talk a little bit about Azure machine learning and then AutoML, which is some cool stuff. So jumping straight in, machine learning, what is it? Good question, right? So there's lots of different points of view. I view it as being a subset of artificial intelligence. And in fact, I kind of view it as being applied artificial intelligence, but we'll circle back to that. So since it's a subset of AI, well, what's AI? Traces back 1956 is kind of whenever the typical date is. The idea is kind of twofold. One is to determine if it's possible or find a way to do something that demonstrates intelligence or acting or behaving rationally as a goal. That's one. So for a computer to do something that seems to be logical, intelligent, rational, something that a person might consider as being intelligent. Generally speaking, there's this concept of perceiving an environment, learning about that environment, and then acting in some way to reach some goal, generally in a flexible way, so it's not just a set of predefined steps, but something that is determined. That's one sort of view of it. There's lots of areas of artificial intelligence. It is a big field. They include knowledge representation, reasoning, problem solving, planning, learning, natural language processing, perception, motion, and manipulation, social intelligence, and general intelligence. But as a general rule, there's the concept of an intelligent agent is kind of centered in a lot of artificial intelligence world. Moving on to back to my first question, what's machine learning? And I view it as being applied AI plus some other stuff. And the reason that I get away with saying that it's applied AI is that, AI figured out at some point that maybe those people in statistics had some good stuff, and so they took it. And so by including things that are essentially probabilistic and statistically based into solving problems, it allows you to then pull in most of the other stuff that might otherwise not necessarily be considered part of machine learning. It's typically an iterative process. You acquire some data, you do a lot of time cleaning it, manipulating it. Usually you spend most of your time doing that. That's where the time is typically spent. No matter how good the data is, it may not be as good as what you would like. You then typically calculate and refine, or create and refine a model. A model is nothing more than a way of representing stuff and trying to solve a problem. Then you typically train and then retrain the system or model. And then the goal of the whole point is to make it available for use. So you want to expose that model for some sort of production type usage. Generally speaking, there are variations on that theme, but that's typically the pattern. The main type of systems that you'll deal with learning is supervised, unsupervised, and reinforcement. What are each one of those? We'll talk about that in a moment. There's also this inclusion of statistical methods, and in addition to the typical connectionist methods. Okay, what does that mean? So statistical methods, it's stats, right? You should probably know that, especially if you're taking a data science class. Connectionist method is essentially neural network based approaches, generally speaking now with a lot of layers in between, and we call those deep neural networks, right? Because there's more than two or so, or three. And so that's one thing, is that machine learning isn't just using some sort of neural network based approaches. It's not doing just statistics, but it's basically trying to solve mathematically typically problems using, or mathematically oriented anyway, using computers. Generally speaking, the people that do machine learning are data scientists, computer scientists, or data engineers, or they may have some other title that is some variation on that theme. So I mentioned the various types of learning. We start off with unsupervised learning. Kind of talked about this in other topics, but we'll go ahead and go over it for completeness. Basically, you don't have the answer. That's the gist of it. You don't have a label. You don't know what something belongs to, especially in the case of classification. But you know that maybe there's two sets of things, right? You may be clustering things together in some sort of pattern based upon some characteristics. but you don't know the answer when you start, and that's the key difference. You don't know that point X here is part of this particular class. The idea is to group things together that are close to each other, and what close means is generally some form of Euclidean calculation in n-dimensional space. Also, they typically are using something like a k-means type cluster, k-means clustering algorithm, something that basically groups things together. There's variations on that, but that's the basic idea. Is you figure out what things are close together. Things that are close together, if enough of them are all the same thing, then it must be this one same class of things. And it's all about trying to find patterns or structures inside of the data without knowing what the data is to start. So it's a kind of a limited set of things in that regard. Supervised, bit different. You know the answer when you start. You know that this particular data item is classified as something, right? And you generally are doing several different things with that information. You may be predicting between several categories. So you're trying to figure out, given this thing, which one of these n number of categories, and n being greater than 2, does it belong to? Then you may also be doing it between two categories. That's two-class classification, and that's basically it's one thing or the other. Simplistically, it's a binary classification. It may be, is it good or is it bad? Is it male or is it female? Is it a defect or is it not a defect? Those sort of classifications. And typically speaking, you may be doing that to images or any number of other things. You may also want to use it as a means of extracting text, information from text, doing text analytics, doing some prediction and regression, and finding unusual things, so doing anomaly detection. The third type of training, and this one's kind of doesn't get all the attention the other two do, is reinforcement learning. Learning is the idea of where you're trying to model some sort of data and come up with something that approximates it, right? So reinforcement learning, you don't necessarily know what something is, so in that sense, it's essentially unsupervised, but you have a measure of determining how well something did. So you have goals. The goal is to maximize some outcome, and that outcome is determined through some form of a function. You don't really need labeling. It does require, though, having a method to determine what good looks like. Without that method to know how good something is, you don't know how to determine if things went well or not. You may not be able to find an optimal solution, but you will find a solution most likely, and you're going to balance that solution between exploring the entire search space and doing something that you already know. So it's a combination between exploration and exploitation of what you already know, and that's the key concepts of reinforcement learning. So here's the cheat sheet from Azure Machine Learning. And it's all of the different types of algorithms and what is it you're trying to do. So which one of these algorithms is appropriate? So you want to predict between several categories. That's a multi-class classification. You want to predict between two categories, two-class classification, just kind of like what I talked about. There's image classification, anomaly detection, general recommendations, extracting information from text. That's going to be typically something on the umbrella of text analytics. And then regression is when you're going to try to predict a value. So there's lots of different, inside of each one of those, various types of domains and various types of models that one might consider. So what's the difference between data mining and machine learning? You probably have heard those two terms. Data mining can be using machine learning. It might be using machine learning to do the actual mining of data. But it's typically, if you talk about data mining, you're typically talking about a database. That's kind of the pattern that I've seen. So it's about trying to find patterns, extract knowledge, and predict outcomes, typically as something housed inside of a database. And that's pretty much my definition is data mining is machine learning or AI on databases and data warehouses. That's essentially how I define it. So moving on to Azure machine learning. So what's that? And it's a pretty cool set of offerings. It's a simplified way, or it simplifies the process of creating machine learning workloads in a unified, secure, and accessible way. Sounds a little bit marketing, but that's kind of what it is. It does have security. It does make it relatively easy to do things, and it can do pretty much all of it in a unified fashion. You can do things lots of different ways. You can have a mixture of notebooks, and we've talked a lot about those in the past. So you can do Python notebooks, something similar to Jupyter. You can do a drag and drop sort of thing. It's not quite as expressive perhaps as what you can do inside of notebooks. You can do things in R if you like R, so R scripts and notebooks. There's a Visual Studio extension for it, so if you want to work inside of Visual Studio, you can do a machine learning command line interface if you're old school and like getting down to a command line, or you can utilize frameworks such as PyTorch, TensorFlow, and so on. So if you're doing some interesting work there and using one of those frameworks, then it definitely supports it. And you can also do automated machine learning, and that's what we'll talk about here in a little bit. And it's really cool. I'll just do a little bit of a spoiler there. It's a good thing. It does enable things like ML Ops, which is the basic idea of being able to deploy and lifecycle management of your machine learning oriented projects. The idea being that it is a continuous and iterative process where you continually refine and train on your data and improve the model over time, also addressing things such as concept drift, which is, it may mean something today and it might mean something different tomorrow. So being able to address what the differing values mean is an important sort of characteristic and something to be keeping in mind. If you want to go out and create a machine learning environment, you search for ML or machine learning, and it'll show up there. It's in the third item, machine learning. You create it. You basically say that you want to create it. It says, sure, why don't you go ahead and create it. Generally speaking, you don't necessarily need to do a whole lot here. You basically will pick a subscription, resource group, and a region. Resource groups are just that, ways of grouping resources together, primarily so that you can later remove them. That's how I use them anyway. There's other purposes, but that's my primary goal, especially from a demo perspective. I want it to go away. You will need to give it a name and a region. A region is basically a location, like a data center to run in. In this case, it's central US, lots of different regions. Sometimes there's price differences across regions, so you may want to spend a little time poking around. For this sort of thing, I don't need to do much, but if you're doing this in a real world scenario, you may need to be, and likely will need to be, doing things with networking, as well as some advanced features like bringing your own certificate and so on, which is around security and privacy and all that good stuff. And you may want to associate a tag with this for potentially financial reasons and tracking and so on. Once you've failed out stuff, you click on Review and Create. If everything looks good, you click on Create. It goes through the process of spinning it up relatively fast, not as slow as some things. In that case, it doesn't really show exactly when it finished, but it's pretty quick compared to some things. When you click on Go to Resource, it lands you on this sort of landing page, and like a lot of things inside of Azure these days, you don't actually get to see the thing, right? You see a portal page that shows you where the thing is accessible from, and that's what Azure Machine Learning Studio is the way you actually go do what it is you want to do. All this other stuff is around managing the resource inside of the Azure environment. It's a common pattern. Lots of the offerings are going this direction. Keeps the central portal relatively straightforward while allowing you to have a rich experience elsewhere. When you click on that link, it launches you into the Azure Machine Learning Studio. This is a pretty nice web portal that puts things front and center that you might want to do, like create something. And so you can poke around, lots of different ways of doing it. You can do notebooks, automate ML, and so on. In this case, you may want to do something like create a hello world sort of thing. So I went through and I created essentially an example that is spun up the hello world sort of typical sort of first thing you run. Really complex Python there, print hello world without the comma, but with an exclamation mark. The next thing is, okay, you got a notebook, where does it run? So you need to add some compute to your workspace. You give it a name, you pick the class of machine. Underneath the covers, it's pretty much creating a virtual machine for you. And then basically then you can, once you have that compute associated with the notebook itself, then you can run it and see the output. So that's a very tertiary treatment of a very powerful environment, but you get the basic idea is that you can have notebook-based development inside of a compute-managed environment. Moving on to the fun topic, though, which is AutoML. So what is it? And this is the part that's cool. Once you've done enough of the data science type work that we've been doing in this course of classifying stuff, you'll start seeing a lot of times it's not all that exciting. You try a model with your data, so you get your data shaped the right way, you get it partitioned into your labels and your features, and then you run it, and then you check and see how it did, and then, oh, it's not good enough, so you tweak some stuff and run it again. Maybe you switch out to a different approach, different model, different algorithm, and run it and do it again, and so on. So it does a lot of that kind of experimentation. What this does for you is automate that process to where you're running those models. Essentially, you're running hundreds to thousands of models to determine which is best based upon your criteria. That means that you basically specify what is good look like. So is it area under the curve? What is the thing that makes it good? Is it accuracy? Whatever those things might be. And then it figures out, well, which one gives you the best results. It's quite useful for things like classification, regression, and forecasting. Once you figure out what's best, you can deploy it out to a web service for easy consumption. So it makes it really easy to go from some data to a web service, and that's the basic idea. So in this case, we're going to walk through an example. You can certainly do so yourself if you have access to an Azure subscription. And I start by creating a data set. I select it from some local files. I leave the data as tabular data because that's what it is. And I basically upload it. I leave things to the default data store and click on next. I change the column headers to all of the files have the same headers. The idea being, if you're potentially uploading not just one file but multiple files, those files might have slightly different headers, meaning then that you would have to deal with some sort of a aggregation or resolution of those categories. Since it's a single file and since the file has a header, I say they have the same header. And then I remove those that I'm not interested in doing any kind of processing on. In this case, it's just day of the week because it's not terribly useful for this particular example. I verify the details, make sure that it looks right, and then I click on create. And that's created my data set. The next thing is to create an automated ML run. I select the data set of interest that we just created. I select, or I have to create a cluster for it to run on because it will require more than one computer. In this case, it does allow you to do essentially auto scale, right? So I say at least so many numbers. In this case, I say 0, but at most 4 nodes. And then you tell it how long, whenever something is idle, should you start turning things off. You're trading off there the time it takes to spin it back up when you go to use it to the cost associated with its sitting there idle for potentially 2 minutes and not doing anything. And also you do have the choice there of specifying a low priority virtual machine versus a dedicated. Low priority is kind of similar to that spot instance sort of concept that Azure has, where something is, if it's available and you can use it, then you'll use it. It's a lot cheaper to go that route, but it's kind of a nuisance if you just want to do one thing and then you're done. The next step is to configure a run. In this case, I'm telling it what the target is. I'm telling it what cluster it should run on. And then I basically say, hey, this is doing some classification and also view some additional settings so I can do some configuration. What I'm going to configure is the how long I want to let it run. So what is the exit criteria? Is it both the metric threshold or just time? Also, how do I validate it? In this case, we're doing k-fold cross-validation with just 2 folds or 2 cross-validations, and then 5 concurrent iterations. That means that things are running in parallel on this thing, so that's part of why it can go reasonably quick. The next step is to go through and click finish. You're basically saying it's ready to go. And then the next step is to wait a little bit while it does its thing. Once it's finished, you'll get back some results of the first run. And then over time, it'll finish up and you can actually take a look at the whole thing by evaluating the results. In this case, it basically ranks it based upon the criteria that we've given it, which is AUC weighted. And it, in this case, turns out that the area under the curve, area under the receiving operator curve is actually the best one that does there is the voting ensemble approach. You can see all of the other ones in the list that it tried, and that list goes on for quite a while. So given that that is the best model, the next step would be to deploy it, right? So we've taken it, we've ran it through the data, we got a reasonable sort of AUC weighted value of 0.948, give or take, so about 0.95. So pretty good. So we want to deploy it out to make it available for consumption. In this case, you select the compute type, either Azure Container, or you could select Kubernetes if you're using AKS. And then basically then you wait for it to deploy. And at the end of that, you have a REST endpoint and a Swagger UI. So we've created a consumable web service that will deliver the ML model that we just created in a few clicks for consumption. Now, I'm oversimplifying this a great deal. Don't go out and say, oh, this degree is wasted, because you got to know how to interpret those results, how to tune it, how to shape your data, how to cleanse your data, lots of other stuff. But it is important to know this is a tool that's available. Once you've mastered the concepts, then you may start moving into using this at scale. And also, you can certainly deploy custom models, the same basic approaches. And with that, I've reached the end of the material I have presented. If you have any questions, let me know. It's what I'm here for. Stay safe, and we will speak again next week.